Okay, so now we're moving on to one of my favorite topics in math. You know, I'm willing to bet that I probably say that a lot in these videos, my favorite topic, because I love math. But this stuff, this is some serious thinky stuff that it's going to lead to. And one of my favorite problems, the super burger problem, that you're going to see this year. Now, I say favorite because it's so amazing how much it makes you really work your brain. So anyway, we'll get there. A set is a well-defined collection of elements. Symbol, right? We put them around it. So if I were to say to you, my set is all natural numbers, right? Oops, there we go. I want to actually use the pen to write with. I want to say all natural numbers, so capital N for that. What we're looking at then, if you remember natural numbers, that's your counting numbers. 1, 2, 3, dot, 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 on and on forever. So a set. I could say all the people in the classroom right now, but it's actually just me as I'm making this video. So it's a set of 1. I could say all of the 7th graders in the classroom right now. That'd be the null set because there's nobody but me right now. But when you're listening to this, there might be others at the time, so there could be a few of you. Element of a set is a member of the set. It looks like it's like a funky E. So if I said to you, again, back to that natural numbers example, and we said 1, 2, 3, dot, 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 forever and ever, we could certainly say that 1 is an element of the natural numbers. So there you go, an element, a member. Like, anybody in the classroom with you at this point is a member of the set of members of this classroom. A subset is a set of elements from a given set. So back to the idea of natural numbers, right? You could say that 2 and 3, right, is a subset, right, of the set of natural numbers. Or I could pick any person in the classroom right now, and you're 2 of you, 3 of you, 1 of you, none of you technically, and they'd all be considered subsets. The whole set of you is a subset. There's different ways to talk about sets. One form of a set is a roster form. So a listing of all the elements in a set. So here I took this out of your book. Roster form is one way to write sets. Rosters list the elements of a set within braces. For example, you write the set containing 1, 2 as 1, 2. And you write the set of multiples of 2 as 2, 4, 6, 8. And obviously dot, dot, dot because it goes on forever. So listing them out is called a roster. So if I listed all your names out, that would make you be the roster form of the set. Yet another way to describe what a set is called set builder notation. It's a method of writing a set so that it describes the properties an element must have to be included in a set. And it looks like this, and there's a certain way to read it. For example, this is roster form, right? 2, 4, 6, 8. Let me make that a little bit bigger for you. This is roster form, 2, 4, 6, 8. Set builder notation looks like this. X, so notice I put the braces on. X such that, that's how you read this line, is such that. So X such that X is a multiple of 2. You read this again as the set of all real numbers X such that X is a multiple of 2. Now, let's say we're talking about natural numbers, so which we've mentioned a couple times. You'd write it like this. You'd say the set of all real, here, X such that X is a natural number. And that's set builder notation. So X such that X is a natural number. The most important part of that is the braces, the such that, and the description. So set builder notation. Now here's one's probably going to blow your mind a little bit. Empty set. The set that contains no elements. The symbol is the null set right here, right? Again, we also call it the null set. So symbol is like the 0 with the slash. Is a subset of every set. So even if I talk about the set being the members of this classroom, the null set is still a subset of that set, right? So that in fact I'm in here by myself, right? Then it's me. I'm the only member of the set right now, but the null set is still a subset of that. It's a subset of every set. So the set with no elements is a subset of every set. Okay, to break it down even further, the universal set is the set of all possible elements. My example over here, when working with sets, you call the largest set you are using the universal set, or the universe. And we'll talk about complement in that in the next slide here. But the idea is, if I said the set of all people on planet Earth, that's everybody, all of them, that's the universal set. But if I said, no, my set is instead people in my classroom, and that would be the universe. That'd be the full set, and we can make subsets of that. Remember, the subset, or the null set's always a subset of every set. That's something important, because that comes up on a quizzes and tests frequently. So, but again, all the elements. So if I said all natural numbers is my set, so that would be every natural number, 1, 2, 3, 4, 5, 6, 7, on and on forever. 2 and 4 are a subset of that. 297 is a subset of that. The null set is a subset of that. The complement of a set is the set of all elements in the universal set that are not in the set. Notation is A prime. Let me make sure we understand what it looks like. A prime, or whatever prime. If set is C, then it's C prime. So these have to be members of the set that are not part of the subset. So okay, let's try this. I'm going to grab on the slide here and show you what I'm talking about. So let's say that my set is, we'll make a set of 5 things. A star, right? A question mark, an exclamation point, the letter Z, and the number 3. Okay, so let's say that's my set, and I just put them in roster form. Now, I could say that my subset is going to be star, exclamation point. And I'm going to call that set A. A prime, right, that's the complement, is going to be everything else that is not listed in A. So it's going to be question mark, the letter Z, and the number 3. So A, now here's the cool thing, A and A prime, when put together, make up the universal set. Again, the universe. Okay? So I could call it B or B prime, whatever I want to call them. But again, so if this is my universe, 1, 2, 3, 4, 5 items, these 2 are A, the complement of A are the other 3. Hopefully that makes it a little bit clearer.